Hey, welcome to Busy Waiting. In this video I'm going to show you what git commit squashing is and how to use it before merging your feature branch or opening a pull or merge request. Let's talk a little about the environment that I'm going to use to demonstrate that. I have a Git repository in which I have two files, file 1 and file 2, and file 1 is changed on a feature branch, while file 2 is updated on the master branch. I do it like this so that I don't have to worry about merge conflicts. So I'm assuming a clean merge after I have finished all of my changes on the feature branch. I'm still modifying file 2 on master so that you can see the sequence of commits in the history when doing a plain merge versus rebasing and squashing the commits. The chronology in my example repo is as follows. I have an initial commit I on the master branch in which I have created two files, file 1 and file 2. After that, I created a feature branch and did commit A. Then came commit X on the master branch, followed by commits B and C on the feature branch. Finally, there's commit Y on the master. All commits on the feature branch happen in file 1. All commits on master modify file 2. Now, let's imagine that commits A, B, and C are implementing a feature you are working on. For instance, commit A can be the bulk of the feature. After committing, you realize that you broke the build and did commit B to fix it. And after doing some testing, you have some minor bug fixes in commit C. So now let's check this setup in the Git repositories. I have two branches, master and feature. The log on the master looks like this. I have commits Y, X, and I. Now let's change the branch to feature. And here the log is as follows: C, B, A, and I. The order in time between A, X, B, C, and Y is the one I described earlier. First was commit A on the feature branch, then commit X on the master, then B and C on the feature branch, and last Y on master. If we do a git log -p to see what each commit changes, we can see that commits A, B, and C will add lines A, B, and C respectively to file 1. In the same way, commits X and Y add lines X and Y respectively to file 2. First, let's see what happens if we merge branch feature into master directly. Let's do that by checking out master and running git merge feature. You can see that there is a merge commit because we cannot fast forward due to the timing of the commits. And going backwards, the time sequence of the commit is kept, like Y, C, B, X, A, and I. This is something we might not especially want or like. I wouldn't want commits for build fixes on my feature or minor bug fixes to appear on my master branch history, especially mixed with existing commits on the master. Also, if conflicts appear at merge, it's better to resolve them on the feature branch. And this can be done by rebasing. Rebasing the feature branch over master will make it look like this. It will reapply my A, B, and C feature commits on the feature branch, as if the feature branch was pulled from the latest commit on master. It is like having the feature commits done after X and Y. If I now do a simple merge from feature to master, the sequence of commits on the master will be going backwards C, B, A, Y, X, and I. This ensures that the commits related to my feature are kept together one after another and not mixed with other stuff that appear on the master branch in the meantime. As you can see, there is no merge commit since this merge can be fast forwarded. The head can be moved to commit C. So let's come back to the initial state where we had the feature commits all on the feature branch. To do a rebase, I check out branch feature and run git rebase master. After that, in order to merge to the master branch, I do a checkout on the master branch and run git merge feature. If I do a git log on master now, then the sequence shown is that my feature commits A, B, and C come after master commits X and Y. So far, this does not solve the issue of having minor bug fixes or build fixes on the master branch as individual commits that pollute the history of master. Here's where commit squashing comes into play. So let's revert to the point where we did the feature branch rebase over master. Squashing the commits will create a single commit, let's call it D, that will contain all the changes in commits A, B, and C, and we'll replace them on the feature branch. First, we should make sure that we are on the feature branch. Instead of doing an automatic rebase, we can do an interactive rebase by passing the -i argument to git rebase. This will open up a text file which will allow us to specify the way in which a rebase is done. The options here are pretty much self-explanatory. Pick means that the commit will be applied as an individual commit. R, or reword, will use the commit as pick does, but you will have the opportunity to edit the commit message. Edit gives you the ability to amend the commit. S, or squash, is what we actually want to do here. We will combine this commit with the previous commit so that we just get one. Fixup is the same as squash, but it will remove commit message. And X or exec gives you the ability to run a command using the shell. So what we want is S for squash. We'll keep commit A as is, so we'll choose pick here. But for commits B and C, we'll use squash. This means that B will be applied in the same commit as A, and so will C. Let's now save and exit. Now we can edit the resulting commit message, and let's call it D, and keep the previous commit messages as well. Let's do a git log -p again on the feature branch. We can see that now we have just one commit, which is D, which has the changes from A, B, and C, similar to what is displayed in this picture. Now, if we do a merge on master, the master branch will look like this. The latest commit will be D, preceded by Y, X, and I. The merge can be fast-forwarded, so there is no merge commit. Let's go to the shell and check out master, and do the merge from feature. Also, git log shows you exactly this sequence of commits that we described. D is the latest one from the feature branch, and Y and X were already on master. This is it. I hope you got some new knowledge from this video. Don't forget to subscribe for more tutorials from us. See you next time.